Hi, I'm Ryan from Cyborg Dynamics Engineering, and today I'm excited to show you how to use our new open source CAN visualization tool, CyderVis. Before we jump into the demo, I want to quickly share why we built CyderVis. At Cyborg Dynamics, we've been developing robotic systems for quite some time, and CAN has always been our serial protocol of choice. One thing we love about it is how you can plug into a vehicle's CAN network and immediately start understanding what's going on. Unfortunately, getting that capability often comes with a hefty price tag. Many CAN adapters and visualization tools are expensive or locked behind proprietary software. Our goal with CyderVis is to bridge that gap by creating a reliable, open source CAN viewer that makes working with CAN networks simple and accessible, whether you're a hobbyist or a professional engineer. And because accessibility matters, we've made CyderVis cross-platform, running seamlessly on both Windows and Linux. Alright, let's get into how to get CyderVis up and running. I'll start on our software page. This will be linked in the description. So from the software page, you can see CyderVis is listed here. Just scroll down to the Getting Started link. That takes you to the documentation for CyderVis. From the documentation, at this point we have two guides, Getting Started on Windows and Getting Started on Linux. I'm on Windows, so I'm going to run through that one first, and I'll add through the Linux sections where appropriate. Once the program's actually set up and running though, it works the same regardless of which system you're using. So to get to the Windows guide, just click on the Getting Started on Windows link. The only prerequisite for CyderVis on Windows is our Windows CAN Utilities program, WinCanUtils. If you don't have WinCanUtils installed, I've made another video on how to get that running, so I'll link that in the description as well. Otherwise, you can go and follow the instructions on the README here. I'm going to assume now you've got WinCanUtils installed, so I'll move on to step 2. Step 2 is to download and run CyderVis. I'm just going to click on the CyderVis releases link, which will take me to the releases of the CyderVis GitHub page. Go to the latest version, click on the assets drop-down, and select the Windows zip folder. With the zip folder downloaded, you want to extract it somewhere. So to do that, I'm just going to open up my downloads folder and choose to extract it here. Now CyderVis has been extracted into the CyderVis v0.0.3 Windows folder. You want to open that up and run the executable that has the same name, CyderVis Windows. We've now got CyderVis running on Windows, so I'm going to go back to the Getting Started guide and move on to step 3. Step 3 is to start a CAN server. This is where you will need WinCanUtils installed because running the CAN server command is part of that package. I have the Candlelight firmware installed on the CAN adapter I'm using, so I'm going to be using the GS-USB driver. To start a CAN server, I'll just open up a command prompt and type the CAN server command, the driver type, which is GS-USB, and set the bitrate with the -B command to 1 megabit. So it's -B, then 1 million. As you can see here, we get a message saying the GS-USB driver is connected to a CANable device, and the CAN server interface is CAN 0. It's important to note the CAN server must be running whenever interacting with the driver through CyderVis. If the CAN server stops for whatever reason, CyderVis will also lose connection to the adapter. That's all the instructions to get CyderVis running on Windows. I'm going to run through the Linux specific steps now, and then I'll move on to using the actual program, which is the exact same for each operating system. Feel free to skip over the Linux steps if you're a Windows only user. I've booted up Ubuntu now to show you the Linux specific steps, so let's get into the Getting Started on Linux guide. The first thing we're going to do is download and run CyderVis. Just go to the CyderVis releases page on GitHub. Under the most recent version, click on the assets drop-down and then the CyderVis linux.zip. All we need to do now is open the downloads folder and extract it here. That's going to create the CyderVis Linux folder, which we can just open up and you can run the CyderVis Linux executable. Going back to the guide now, let's move on to step 2. On pretty much any of the mainstream Linux versions, the CAN driver is built into the kernel, so you shouldn't have to install anything. If you find that for your version of Linux you have to do something specific, let us know in the comments and we'll update the guide so people with the same problem know what to do. With that said, let's bring the CAN interface up. So to do that, open a new terminal, and the first thing I'm going to do is just search for what interfaces are available. To do that, you can run the ip-link show command. You can see here I've got an Ethernet, a wireless, and a CAN adapter. The CAN adapter I have connected is just a DSD-Tech SHC30A running Candlelight firmware. You can see the CAN adapter is named CAN 0, so to connect to that, we can just run the command in the guide here, which is sudo ip-link set CAN 0 up, type CAN, and put in the bitrate. I'm working with a 1 megabit bus, so I'm going to type in 1 million. you can verify the interface is up by running this IP link show can0 command. The interface is now listed as up. Those are the only steps specific to Linux, so let's get on to actually using the program. I'm briefly going to show you what the hardware looks like set up on my desk, so you know what I'm working with. We make a range of CAN-based devices that are useful for robotics and other industrial applications. We also sell interconnect to make the hookup for prototyping really easy. On the bench here, I have a 6-way data tap, 2 120 ohm termination resistors, and our Cyder IMU. The Cyder IMU is configured to spit out tilt sensor data at 1.6 kHz. The other device connected is the adapter itself, the DSD-Tech SHC30A. We aren't affiliated with DSD-Tech at all, we just like how they've packaged up the adapter and it's very accessible to us on Amazon. If you're into robotics or building anything industrial, check out our store cyborgdynamicseng.com/store, also linked in the description. It contains the products we currently have available and there's a lot more coming out soon. Now you have a good idea of what we're working with, let's get into how it looks in CyderVis. I currently have a CAN interface running called can0. Now, I'm using CyderVis on Windows at this point, but Linux is the exact same. If you've brought up an interface, it'll have a name similar to can0. Just make sure the right interface name is in the CAN interface box and click Start to start streaming the data through that's on the CAN bus. As you can see, I'm getting 2 messages come through. The first one is the tilt angles output from our IMU, and the second one is just a status message which comes through at once per second. The fields in the receiving window are the timestamp, which is the timestamp for when the program was started, frequency in hertz for how fast the message is coming through, CAN ID. You can see both these are extended IDs because they have the full 8 hexadecimal digits. 4 basic IDs only show up as 3 digits. Message names will come into play when we start using the DBC file, and finally is the data fields. When we decode the message, this will actually start showing up as the decoded values. Another thing important to mention is at this point we only support regular CAN, which has a payload up to 8 bytes. We do not support CAN-FD, which can go up to 64. CAN-FD is a feature we're looking to add in the future. The CyderVis project is open source, so feel free to jump on and make some contributions if you'd like to see it developed further. Now we've got data streaming through, I'm going to jump back to the Getting Started guide and move on to the next step. Step 5 is to adjust the display options. You can see at the moment we have 3 optional display toggles. Those are CAN ID format, CAN data format, and time format. So I'm going to open up my CyderVis and just show you what each one of these does. CAN ID format can toggle the CAN ID field between hexadecimal and decimal values. CAN data format does the same thing for the data fields, so you can see toggling it puts them into decimal values. And the time format can be flipped between frequency in hertz and period in milliseconds. I like to typically view CAN data in hexadecimal, so I'm just going to leave that as the default setting. Let's move on to the next step, which is to load a DBC file, which allows you to decode frames into actual data. DBC files just tell the program how to decode CAN frames. We've created one for the IMU, which is available on the GitHub page. It's linked in the Getting Started guide. I'm just going to jump to that link and download the IMU DBC file. This DBC file is complete for our Cyder IMU. Now I've got it downloaded. To use in the program, the easiest thing to do is to drop it into the folder where CyderVis is located. So in my downloads, I'll just grab the imu.dbc and drop it into CyderVis Windows folder. Moving back to CyderVis, I'll open up that DBC file and restart the interface. With the DBC file loaded in, the messages are now decoded into their actual values. The 8 data bytes of the tilt angles message now shows up as pitch and roll, which are float values. The status message is just an enum, so it's just going to show the raw decimal value still. If you want to create your own DBC files, I'd highly recommend reading through this link we've put in the CyderVis documentation to the Open Vehicles DBC primer. With the IMU data decoded, I'm now going to show you how to plot the data. Plotting data in CyderVis is super straightforward, but you must decode the data for it to be plottable. Opening up CyderVis, to plot the data, you just need to go to the Plot tab and click on the names of the fields you want plotted. So I've selected pitch and roll. You can see roll is in that dark green, and pitch is in the cyan color. The legend shows you which one's which. With the data being plotted, I'll just roll the IMU a bit and then pitch it, and you can see it's getting plotted in real time in those graphs. To stop showing a particular field, you can just click on its name again and it drops off the plotting. The last thing I'll show you how to do is transmit frames. To do this, you need to open up the Transmit tab, click the Add New button to add a new frame. You can see the options are a delete button, a send checkbox, a cycle time field, an extended ID checkbox, a can ID field, and a data field. Clicking delete just deletes the row, so I'm going to delete it and add it back. If the cycle time is 0, the message will be sent once every time the send button is clicked. If we give the cycle time a value, say 100 milliseconds, we can then click the send box and it will continuously send this message until the send box is unchecked. The can ID box sets the frame ID of the message we're sending. If you want to just send a basic ID, you can send anything up to 7FF. You can see I can hit the send box here and that works just fine. Values above 7FF are invalid for a basic ID, so if you try to click send, you'll just get an error. At this point, we need to use an extended ID, so to do that, I can just click the extended ID checkbox, and now it's being sent as an extended ID. Message IDs below 800 can, however, still be sent as an extended ID. So 7FF as an extended ID is a different ID to 7FF as a basic ID. At the moment, the data I've been sending has had a data length of 0. No bytes of data are actually being sent with the message. To add data bytes, you just need to type the data you want to send into this data field. Bytes will automatically be separated by spaces as you type. So if I want to send the data 00112233, typing that into the data field creates the 4 data bytes, and when I click send now, it'll be sending the 7FF extended ID message with the 4 data bytes I've typed there. That's all there is to it for CyderVis. If you have any feedback or if you find any issues with the software, the best way to let us know is to go to our GitHub page and open up a new issue. Alternatively, you can just let us know in the comments to this video. If you're in the market for CAN-based devices, check out our store at cyborgdynamicseng.com/store. Subscribe to stay tuned to updates on CyderVis and any other projects we're working on. Thanks for watching.